One of the basic things one could ask is what a landing craft air cushion, or LCAC, actually is. How many tanks can do an LCAC carry? Can it carry one at all? And why is the landing aircraft cushion so important to the amphibious operations for the US Marines? Stay tuned as we'll be answering all these in today's video. Hey folks, welcome back to the channel. Before we get into the video, kindly note that the information provided in this video is for educational purposes only. Without further ado, let's dive in. The majority of discussions on future amphibious combat capabilities in the United States center on ships, planes, helicopters, and vehicles. The Navy is developing contemporary amphibious warships like the LPD-17 class and preparing for the LX class in the future. With the deployment of the first squadrons of the F-35 Joint Strike Fighter SHORT-TAKEOFF vertical landing variant, the Marine Corps aviation is improving dramatically. The F-35B is being used on the Navy's amphibious assault ships with flight decks, the LHA and the LHD. The MV-22 Osprey, UH-1Y Venom, AH-1Z Viper, and new CH-53K King Stallion heavy-lift helicopters are among the Marine Corps' rotary wing fleet. Ultimately, the Marine Corps' amphibious combat vehicle program will develop new fighting platforms capable of self-deploying from ships at sea to the shore. The development of land and sea forces from platforms at sea onto a potentially hostile shore is known as amphibious operations. Modern amphibious forces can maneuver in the air, deploying Marines and vehicles behind the shore using the MV-2022 and helicopters. Nonetheless, the movements of soldiers, equipment, and materials from ships to land is at the heart of amphibious operations. For amphibious operations, the Navy and Marine Corps have fleets of boats and vehicles, but they can only transport a small number of troops and light vehicles at moderate speeds. Again, for the time being, the Marine Corps rely on the Navy's fleet of specialist vessels, the landing craft air cushion, to get substantial forces from ship to shore. The LCAC changed amphibious operations when it was first deployed in 1984. The LCAC is a water-resistant, high-speed air cushion platform that floats just above the surface. It can transport huge payloads and large groups of Marines not merely to the water's edge, but also over the beach from a good deck of amphibious ships stationed up to 100 miles at sea. The LCAC can transport the Marine Corps' largest vehicle, the M1 tank, and with a cargo capacity of up to 70 tons and speeds of up to 40 knots. The LCAC 100 class vessels are designated as ship-to-shore connectors and are built with similar configurations, dimensions, and clearances to the Navy's legacy LCACs to ensure compatibility with existing well-decked equipped amphibious ships, as well as the Military Sea Lift Command's expeditionary transfer docks. The first two SSCs, LCAC 100 and LCAC 101, are largely utilized for crew training. The Navy will use the LCAC 102, the third SSC, and all subsequent examples of the series in operational roles. These hovercrafts, like their predecessors, were built exclusively for transporting the US Marine Corps ground combat units between the Navy's bigger, deep draft amphibious ships and unprepared beaches. Humanitarian assistance and catastrophe response will be secondary missions. The craft can make ship-to-shore transits across a radius of 25 nautical miles, allowing bigger Navy ships to stay in the relative safety of offshore waters while conducting amphibious landing of troops, vehicles, and equipment in restricted regions. They can also operate day or night, regardless of the tides, water level, underwater obstructions, ice, or mud, giving Naval Expeditionary Strike Group commanders more operational options in terms of ground combat force insertion and extraction. This capability, according to Textron, will allow the craft to access more than 80% of the world's shorelines. It will also be critical in hazardous situations where relief vehicles and equipment will be transported ashore in ports that have been damaged by disasters, rendering their berths unusable by deep draft vessels. Each SSC has a length of 92 feet and a height of 26 feet, a beam of 48 feet, and a crew of 4 that includes a pilot, co-pilot, loadmaster, and deck engineer. The craft's large open deck spans 1,608 square feet and can hold up to 74 tons of various cargo, including main battle tanks and other armored vehicles, support vehicles, and heavy equipment. An enclosed personnel transport module separates the cargo deck and can hold 145 combat-ready troops or 108 casualty victims. A quartet of Rolls-Royce MT-7 6,168 HP gas turbines supplies power, allowing each craft to attain speeds up to 35 knots even in sea states 3 and 4. The engines are controlled by a fly-by-wire joystick, allowing the vessel to be operated by only 2 bridge crew members. Meanwhile, the aluminum and composite design provide improved corrosion resistance, resulting in lower life cycle maintenance costs and 30-year operational service life. Many amphibious warships have large, enclosed compartment in the stern that allows LCACs, amphibious vehicles, and boats to load soldiers, equipment, and supplies directly from the ship's interior. When fully laden, LCACs can move quickly across the ocean and over land, transporting huge groups of Marines, their combat gear, and fighting vehicles in action. LCACs can also assist with evacuations, lane breaches, mine countermeasure operations, and the supply of marine and special warfare equipment. In reaction to the development of modern information, surveillance, and reconnaissance equipment, as well as long-range precision-guided weapons, the Navy and Marine Corps are increasingly aware that the nature of amphibious operations must alter. The Sea Service faces a difficult task in getting huge forces ashore quickly and in combat shape. The movement must be accomplished swiftly and from ships operating at a great distance from land. The Marine Corps sought to achieve this goal by procuring new armored battle vehicles capable of making extended, high-speed transits to shore. This objective will be impossible to achieve for several years. In order to meet the evolving needs of amphibious operations and a Marine Corps force structure that was rising in both weight and complexity, the Navy realizes it needed to recapitalize its fleet of LCACs. The new ship-to-shore connector, which replaces the ancient LCAC, represents an evolutionary step forward. The SSC's payload will be raised, and its dependability, availability, and operating expenses will be reduced. The SSC will also have a more powerful Rolls-Royce engine and a new L3 command, control, communication, computers, and navigation suite. While reducing the need for manpower, it will increase the navigation and tactical reaction. The fact that the SCC was designed by the Navy is an unusual aspect. The Navy design team used an evolutionary design method to develop craft-level requirements as well as particular system-level functional requirement papers. In addition, the Navy prioritized reliability in the SSC design. When the Navy did the concept design for the new ship-to-shore connector, they took the top 25 reliability issues from the LCAC and they designed those out. Things like going from 4 gearboxes to 2 gearboxes, 4 lift fans to 2 lift fans, the orientation of the engines, the aluminum skeleton, said a senior official of Textron Land and Marine Systems, the company that won the competition to build the SSC. The SSC will be easier to maintain and run than the LCAC as a result. The first modern SSC was completed by Textron Land and Marine Systems. It has also given the Navy a significant boost in terms of its industrial base. Textron spent around $45 million to improve its New Orleans, Louisiana manufacturing site with automated welding and other time and cost-cutting advances. Textron also put money into improving the production of some of its key suppliers. Perhaps one day the Marine Corps will have high-speed armor amphibious vehicles that can not only transport a squad of Marines from the ship to shore quickly, but also perform high-intensity combat operations once they arrive. Until then, the LCAC and its replacement, the SSC, will provide a vital link between the amphibious combat fleet at sea and the Marines on the ground. Is landing craft air cushion crucial to the US? Do let us know in the comments section below. Also, don't forget to smash that like button and also press the bell icon to get notified about our new videos. If you enjoyed this video, please check out our other videos.